Good morning, Tehmina Khan is here in TKMaths is fun. In today's video, we will continue the learning of topic differentiation, which is the part of the syllabus of Year 11 further maths. And in Cambridge IGCSE and O level, it is called additional mathematics. We are on the topic of differentiation right now. And in differentiation, we have covered all these topics. And this is the last video on the stationary point, maximum or minimum. So let's see what is a stationary point. I will give you visual understanding as well, but at the same time you should know when you read mathematical language it should make sense to you. So stationary point of a function is a point where rate of change is 0. Why did I use the word rate of change? Because dy over dx is the rate of change of y with respect to x, and this is called differentiation. We know that it gives us gradient function. We have seen that. So in any curve at the point where the rate of change is 0, it means that point is called a stationary point. Now that point could be maximum, minimum, and inflection. So what does this mean? Let's see this in the sketch here. So if you look at this diagram, this is a cubic curve, right? So at this point, point number B, if you see, this is the maximum point in the surrounding. That's why it is called local maximum. Whereas this one in its surrounding is the minimum, and it is called local minimum. Whereas we know if this curve is going up, this point is bigger, the value of y, compared to this one, right? So that's why when we talk about a stationary point, we call it local maximum and local minimum. Yani कि in that surrounding, at the top it is maximum or minimum. So we have already discussed this, and differentiation is represented by f prime x or dy over dx. We have seen that earlier also. So whenever in the question we talk about a stationary point, turning point, maximum point, minimum point, this gives very clear hint that the rate of change is 0 there. So in the equation, wherever you have differentiation, you can put it equals to 0 and solve the equation. So we will see this in the examples. Now what is second derivative? So when you differentiate one time, you represent it like this, or you represent it like dy over dx. The function you get after the differentiation, which is called gradient function, if you differentiate it again, then it is called second derivative. Now what does second derivative give us? This is very important, because the first derivative gave us the gradient function. Now second derivative, if you see here, if the second derivative value is greater than 0, mean a positive answer, it means the turning point over there is local minimum. When I will do the next example, you will understand better, but at the same time you should understand the language as well. Whereas if the second derivative, if the answer of this is negative, then it is called local maximum. Whereas if it is 0, then it is called point of inflection, right? Or it could be local maximum, or it could be local minimum. Okay, now let's see here in this. Same thing I have written here again, little big, so that you can make a note of it. Now let's see the example here. So the equation is given to you, and you have to find out the coordinates of the stationary point, and then you have to determine the nature. Nature means at that stationary point, it is maximum or minimum value. So first of all, for stationary point, we will differentiate it one time. You can write it like this, or you can write it like this, your choice. So when we differentiate it, it will become 2x minus 12. And at a stationary point, you can say dy over dx is equals to 0. Therefore, the differentiation which you have done here, you can put it equals to 0 to get the value of x. Now, in the question it says coordinates. So coordinates mean x and y both coordinate like this. So now I have to find out the corresponding y coordinate as well. So this value of x I will plug in the equation here to get the y coordinate corresponding point. So it will be 6x square minus 12 times 6 plus 8. You can pick up the calculator and figure it out. 36, 72 plus 8. And this will become minus 28. So the stationary point, so you can say the stationary point is, because the requirement of the question was find out the stationary point. So you can say x value is 6 and y value is minus 28. Second part of the question is saying find the determinant of the nature. So I will differentiate it again. Now the symbol is either this one or this one. What will you do now? You will differentiate this again. 2. Now in this derivative you don't have x. If you had x here, then you will substitute this value, the x coordinate of the stationary point. But at this point we don't have it and it is positive. So I can say it is minimum value. Because if double derivative is greater than 0, which means positive, it means the nature is minimum value. So this is example number 2. Just to save time, I have solved it here so that we can do it faster. I have tried to explain 4 questions in this video. So let's do this. Find the coordinates of the stationary point on this curve. Exactly the way I did earlier. You will differentiate it and put it equals to 0. Because at a stationary point, dy over dx equals to 0. Rate of change is 0. So when you will put it equals to 0, this is your first derivative. You get the value of x. So the value of x is plus 1 and minus 1. Now these values of x plus 1 and minus 1, you will substitute back here in the equation to get the corresponding value of y, because we have to find out the coordinates of the stationary point, right? So let's substitute this value of x equals to minus 1 in the equation, and I got the point minus 1 and 3. Now I will substitute x equals to 1. Now we have to see that these are the coordinates of the stationary point, but what is the nature at these points? Is it maximum or minimum? So what will I do? Yes, you are right. This one I will differentiate again. This is the first derivative. So I will differentiate it again to find out the nature. Okay. So here I have differentiated it again. Now in this one I will substitute the x coordinate of these stationary points, because we have to find the nature at these stationary point. So answer is coming minus 6, which is negative. So it is minimum point. And when it is greater than 0, it is maximum point. Now if you see here, I wanted to tell you here, what is written here? When the double derivative is negative, then it is maximum, right? So what should it be? It should be maximum, correct? Yes. And this should be minimum. Okay. Now, so minus 1, 3, you have seen here, is your maximum point, and 1 comma minus 1 is your minimum point, and you have seen it also. Now the demand of the question is sketch it also, right? So what are the key points you should know? You remember the equation, it is given here. This is your y-intercept, and you know the maximum and minimum point. And very important thing, the coefficient of x cube is plus 1, positive, whenever the cubic function has positive coefficient for x power 3, the shape of the curve is like this, right? It could be anything but like this. So let's see here. So what is happening here? This point is marked, this point is marked, and this point is marked. So after that, what is left? Nothing. You just have to give it a shape like this. Okay. Now you can test your understanding here. We have already done quotient rule. So you can see very clearly here that you have to apply quotient rule here. So you can put the video on pause and solve it. I'm showing you the solution. You can match with your working. Okay. And the one thing is very interesting which I have not explained before. Explain why the curve has no turning point. Interesting. So what do you think? Without solving anything, what should come in your mind? When we differentiate it, this gives us gradient function. And when you put it equals to 0 and solve it, you get the value of x. That value of x tells you that you have a stationary point there. But here you have to show it has no turning point. So you know what will happen? Yes, you are absolutely right. When you will put it equals to 0 and try to solve it, you will not get any value of x. You understand? No value of x you should get. It means there is no turning point. So let's see. This is a logical explanation. So first of all, this is the function. I have to differentiate it. And I'm sure you would differentiate it correctly. Formula, I can write it again here for you in case if you have forgotten. It is v square v u prime minus u v prime. Right? Then you will do what? Put it equals to 0. Because we have to check there is no turning point. I'm doing slowly so that you can check each and every step. When you will put it equals to 0, this will go here and disappear. And numerator you are simplifying, which is here. Okay. So what happened? This cancels out. Plus 2 minus 5 is minus 3. Another side you have 0. Are these equal? No, they are not equal. There is no value of x. So it means, let me just see here the formula. This was the formula written here. Right. So this means there is no turning point. So this was something very important. We call it after the differentiation and putting it equals to 0. It is independent of x. Now let's do this last example 4 and then we will end the video. Okay. So the curve is given to you. Y is equals to x cube plus ax plus b. And it is informed to you that there is a stationary point at 1, 3. The stationary point is on the curve. I have to find out the value of a and b as per the requirement of part A. And the point, stationary point is 1, 3. So I can substitute this in the curve. Equation number 1. Now what you will do? You are right. You will differentiate this equation which is given to you. And you will put it equals to 0. Why? Because at a stationary point, rate of change is 0. So you can say at a stationary point, this thing is 0. And I will substitute the value of x here. So I get the value of a equals to minus 3. So I can substitute this in equation 1. This is your equation 1. You can see here. Implies 2 is equals to a plus b. So I will write the value of a here. So b equals to 5. I found the value of a and b. It means I have found the equation without any unknown now. So in this equation, I am substituting the value of a and b. A is -3 and b is 5. So I got the equation here. Part 1 is solved. Part 2. Determine the nature of the stationary point. So I will differentiate it 2 times. First time differentiation gives you gradient function. Then you differentiate it second time. It gives you what? Nature. Now this point is given to you. So at this point I have to find out the nature. So I will substitute the value of x, which is 1, here. And I got what? +6. When the second derivative is greater than 0, it means it is minimum. Correct. Now I have to find the other stationary point on the curve, and then I have to find out its nature. So what will I do now? Yes, you are right. I will put the gradient function equals to 0, because I have to see what is the other point where gradient function is 0. So in the gradient function, let me call it 2 because I'm going to use it. So I can say, this is answer for part C. In equation 2, I will put gradient function equals to 0. Right? Because question is saying find the other stationary point. It means the gradient function is 0 somewhere else also. So I got +(-1). Now the stationary point which is given in the question has +1. So the other point is x equals to -1, because one stationary point which is given in the question has x1. Now this value of x I will substitute back in the equation to get the y coordinate. Right? So let's substitute it here. So I will get here 6. 5, 6, 7, 8. Sorry, it is 7. Okay. So the other point is -1, 7. I have to find out the nature at this point also. So what will I do? Where is the double derivative? Here is the double derivative. In this function, I will substitute the value of x. So we have already calculated it. It's 6x. So this value of x, I will substitute in it. And I will see the answer is plus or minus. Answer is minus, less than 0. It means it is maximum here. So this is how you handle differentiation with stationary point, maximum or minimum. So thank you very much for watching the video. Please press like and subscribe button and share it with your friends. Take care. Allah Hafiz.